Hello everyone, welcome to my channel C.S.E-Pathshala. In this tutorial, we are going to implement neural network using Keras. So our problem statement is we need to consider a simple Keras multiple layer perceptron for the breast cancer classification. Here we are going to have an input layer, a hidden layer, that is a dense layer of 10 neurons and an output layer. Okay, so the dense layer here is a neural network layer that has each neuron in this layer which receives the input from all the neurons of its previous layers. Okay, so this is what we are going to implement in this particular example. Okay, so let's get started. The first thing is we need to import models from the Keras. So we are writing from Keras.models. That means we are already available with models in Keras. Okay. From there, we are going to import a sequential model. Okay. So sequential model is basically a plain stack of layers where each layer has exactly one input tensor and one output tensor. Okay. After importing model, we need to import the layers. Okay, so here I am taking from keras.layers, I am importing activation and dense. The activation actually is an activation function which is need to be applied on the output. Okay, so here we can have different types of activation function, for example, relu. Okay, so for that purpose, I'm taking activation here. And the next thing is a dense. As I've already told above, the dense layer is the regularly deeply connected neural network layer. Okay, and it is the most common and frequently used layer. And if you talk about dense layer, it performs all the operations which are given in the form of an input and it returns the output. Okay, so I'm taking here dense. Then the next thing is I am importing optimizers from the Keras. Okay, so what are these optimizers means? See, optimizers are the techniques or the algorithms or methods, whatever you can say, and they are basically used to change the attributes of the neural network, such as, for example, weights or the learning rate. Okay, and ultimately, this is being done in order to reduce the losses. Okay, so your model is required to get trained, and obviously you need to adjust the weights and whatsoever. So ultimately, we need to reduce the losses. Okay, so therefore optimizers has been used. So they basically solve optimization problem by minimizing the functions. And here we are going to use Adam optimizer that I will discuss ahead in the code. The next thing is from this sklearn data sets. Okay, now I'm talking about the sklearn. So sklearn already comprises of many small data sets. So from that sklearn data sets, I am importing one data set that is load underscore breast underscore cancer. Okay, so I'm picking a small data set of breast cancer from it. The next thing is from sklearn.models underscore selection, I'm importing train test split. Okay, because ultimately I need to split my data into training and the testing. Okay, so for that purpose, I require this library. Okay, so it will be helpful for a method present in it that will split our data into training and test. Now the next thing is I'm going to load my breast cancer data. Okay, so my whole data. Okay, this is a variable I have declared in which I am loading my complete breast cancer data. So load underscore breast underscore cancer. Okay, this data will be assigned to whole data. Okay, from there I am taking, obviously, as we know that this is, for example, a class. This is a library, or I just consider this as a class. Okay, so this is a constructor to this particular class. Okay, and here is an object. Okay, so we have declared an object to this particular class, load underscore breast underscore cancer. From this particular object, I am accessing data. Okay, which has been present in it. load underscore breast underscore cancer. Okay, so there are basically two variables. One is the data, one is the target. Okay, two variables. Okay, so in these two variables, by this I'm getting the data, and by this I'm getting the target variable. Okay, so this will comprise the complete data, and this will comprise your target variable. Next is x underscore data. Okay, that is the whole underscore data dot data. Okay, so I'm giving my x variables. Okay, set of features as in the form of a x underscore data. Okay, and on y-axis I'm going to take the target. Okay, so here is y underscore data, that is small y underscore data. This is I'm taking on the target axis. So this is I'm taking on the x-axis. Okay, the data or all the features, and this is the target variable or the target feature, that is I'm taking on the y-axis. Now next thing is I'm going to split my data into training and the testing. So here I am taking x underscore train, x underscore test. Okay, then y underscore train, y underscore test. Okay, so dividing x into train test, similarly dividing y into train and test. And here is your method, train underscore test underscore split, which you have taken from it. Okay, then I need to feed the data, initial data, x data, y data. Okay, this is what initially I need to feed into the this method. Okay, and it will automatically split your data into training and the testing. By here the test says I'm going to take as 0.30, that means 30% of my data will be for the test purpose, and 70% of my data will be for the training purpose. And the random state here I'm taking as 7. So you can pick any of the random state. There are various random states available in different codes. For example, 42 is also one of the random states. So it's just like a sampling of a data, okay, from your data which has been available. So I'm just picking samples, like a seventh sample from my data, and then again the seventh sample, next seventh sample from my data. It's just like a random state. Okay, now the next thing is I'm going to assign features. Okay, so features can be assigned like this: x underscore train dot shape one. Okay, this will be your features data. Okay, and the next thing is your shape. Okay, so x underscore train dot shape 0. This is how I'm going to print the x train features and its shape. Okay, the next thing is your obviously the assigned features. This will come out to be here by printing. All right. So two things we are available with, that is x underscore train shape 1. Okay, and x underscore train dot shape 0. Okay, so here we are going to print both of them. Then the next thing is I need to prepare 3-layer model here. Okay, so for that purpose, I am going to take, because I have already imported the sequential model, so I'm going to create a model that is a sequential in nature. Okay, so again the same thing. I'm just calling this constructor of a class sequential. I'm assigning an object to it. So model is an object to a class sequential. Okay, so this is how you need to assign any a model or any of an object. Now the next thing is model dot add. Okay, so I need to add a layer to this model. Okay, so the layer which I'm going to add here is dense layer. Okay, then the next thing is 10. Okay, so 10 is your output. Okay, expected output which I'm going to get from the dense layer. Okay, so here is expected output. The next thing is your activation function. So the activation function which I'm going to take here is ReLU. That is rectified linear activation function, which is a piecewise linear function. And here we'll get the output, that is the input directly if it is positive. Okay, if you are giving any input which is positive in nature, so that will be the same as an output. Okay, and if it has been not positive in nature, so the output will be 0. Okay, the next thing is I'm going to give the input shape. So input shape I'm going to give here as x underscore train dot shape 1. So basically, if I talk about shape 1, x underscore train dot shape 1, these are the features. So we are available with 30 features in our data set of breast cancer. Okay, so this will give the value as 30. So we are assigning input underscore shape. That means we are having 30 features here. So its shape will be 30. Okay. Now, this is one dense layer I have added. The next thing is I need to add one more dense layer. Okay, so whatever the output which I am going to get from this dense layer, activation function ReLU will be applied over. Similarly, here whatever the output which I am going to get from this dense layer, so I am getting 10. Okay, so I am assigning 10. So this is the expected output. Okay, 10 units. Okay, so 10 is actually the unit. So 10 units, I am going to get an output of 10 units. 10 unit output I am going to get here. And again, the activation function ReLU I am going to apply over it. And the last one is, that means I need to add one more layer and expected output here is 1. Okay. So here this is, one output I need to give on the output layer. Okay. So the expected output is 1 here. No activation function, nothing I'm going to apply here. Just only one output I'm expecting from this dense layer. So all the computation is been going to perform over the dense layer. Okay. Now the next thing is I'm going to print the summary of the model. Okay, whatever I have created in this model. So the complete summary will be printed. The next thing is I'm going to check the configuration of the model. Okay, so basically get underscore config is your model configuration that specifies what the layers the model contains. What would be the layers and how these layers are connected with each other. Okay, so this is the configuration of the model. The next thing is I'm going to compile my model. Okay, because this is something you have created. You have created your model. You have printed the summary of your model. You have checked the configuration of your model. But I need to run my model. I need to compile my model first. Okay, because in order to perform any of the tasks, I need to compile my model. Okay, so model.compile optimizer equal to Adam. As I have already told that what does optimizer do. So I'm here taking one of the optimizer, very popular optimizer, that is an Adam. Okay, so any optimizer which uses Adam methodology or a technique or Adam algorithm. Okay, that is an Adam optimizer. Okay, so it involves a combination of two gradient descent methodologies. Okay, two gradient descent methodologies it has been going to apply, and this algorithm accelerates the gradient descent algorithm by taking into the consideration exponentially weighted average of the gradients. Okay, and here the algorithm converges towards the minima in a much more quicker rate. Okay, so that's why this is very much useful optimizer. Because as I told that we need to adjust our weights. Ultimately our goal is to reduce the loss basically. Okay, so here the adjustments of the weights will be done, and your learning rate is also been we need to enhance in such a way that we need to reduce the losses. So both of them can be done with the help of your optimizer item. The next thing is your loss. And loss I'm going to take here as a mean squared loss. Okay, so if I talk about the mean squared loss, it computes the mean square error between the labels and the predictions. Okay, so after calculating the square distance between the input, the mean value over the last dimension, it will return your mean square error. Okay, so either I just say mean square error or loss, or basically it's called as a mean square error. Okay, so this is your loss. And the metrics I'm going to take here the same, that is MSE. Okay, so here MSE means the same, that is a mean squared error. Okay, or either you can say mean squared deviation, whatever you want, you can say to it. And it's an estimator basically, which measures the average of the squares of the errors. Okay, so it's going to tell you the average of the squares of the error. Okay, that is the average square difference between the estimated value and the actual value. Okay, now the next thing is I'm going to fit all the values because I have compiled my model. Okay, by these parameters. Okay, now I'm going to fit the values in my model. Okay, so I'm going to take here as a train because obviously we need to take the train to train my model. I need to take the training values. I'm going to take x train and the y train. Okay, so x underscore train, y underscore train. Batch size I'm here taking as a 50. Basically, the batch size is a number of samples which we are going to process before the model is updated. Okay, so the size here I'm going to take as a 50. Okay, and basically here the number of EPOs we are also available with that ahead. Okay, that is I'm going to take the EPOs as 100. Okay, which means that we are going to train our neural network with all the training data for one cycle. Okay, this is what an EPOS means. So, what happens in an EPO is, we use all the data exactly once. Okay, so we are going to run this model, okay, for 100 times. Okay, and for each and every turn, I'm going to use all of my data. Okay, here we are going both. We'll use both. That is a forward pass also and backward pass also together. And both are counted as one pass. Okay, so that means I'm going to make 100 passes for my model. Okay, so an EPO is made up of one or more batches. Here I am taking the batch size as 50. One more thing which I want to discuss is your validation split, that is equal to zero point 0.2. Okay, so it's a fraction of the training data to be used for the validation purposes. Okay, so I'm already available with 70% of the training data. So out of 70% of the training data, I'm going to take 20% of the data for the validation. Okay, so here the model will set apart this fraction of the training. Okay, so model automatically, will take this particular 20% of the data from the training. Okay, and it will not train it. It will perform the evaluation by it. Okay, and the evaluation will be done on the basis of the loss and any of the metrics which we are going to use here. So metric I'm going to use here is MSE, that is mean squared error. Okay. The next thing is verbose equal to 1. So what does this verbose mean? See, verbose is a general programming term which has been used for producing lots of logging inputs. Okay, and we here let you know from the program point of view that everything about you are doing all the time, whatever been happening in this execution, because you need to train your model. So whatever been happening, I need to tell. Okay, from the model point of view. So that is why this term verbose has been considered. Okay, so its value I have assigned as verbose equal to 1. Now the next thing is after training of my model. So with this, my model got trained. I fitted all the value in my model. Okay, and my model got trained for 100 EPOs for the 100 passes. Okay, and the next thing is I need to perform the evaluation. So evaluation can be done on the basis of X test and the Y test. Okay, so let's take the X test value and the Y test value, because I have trained my model already with the help of a training data. Now I need to perform the evaluation with the help of testing data. Okay, so I'm taking X test and the Y test, and whatever the results I'm going to get, I will be storing them into the results variable. Okay, so evaluation is basically for evaluating already trained model, because I've already trained my model to perform the further task. Okay, and my model is trained, and we have also performed the validation. Okay, because I have splitted my data, 20% of data for the validation purpose also. Okay, so this is I have already done, and this evaluate function, basically it will return the loss value and the metric values for the model. Okay, so we can predict by the help of it. We can also predict the actual prediction. Okay, and we are also available with your accuracy also. So it will return your loss and the accuracy. Okay, so here I'm going to print the results. Okay, what are the results, evaluation results which I'm getting? I'm going to print here, and also I'm going to print the loss and the accuracy. Okay, so if we talk about the loss, see, basically loss is a scalar value. Okay, and it is used to minimize. Basically, we are going to minimize. We are looking forward to minimize this loss during our model training. The lower is the loss, the closer our predictions are to the true levels. Okay, so whatever the true levels which are available, if our loss is less, we are closer to its value. Okay, so here I have also taken mean square error for this purpose. Okay, so to be very simple, the loss is a number that indicates how bad the model's prediction was on a single example. Okay, whether your model is going to predict good, whether your model is going to predict bad. If the model's prediction is perfect, the loss is zero. Okay, we don't have any losses. Okay, otherwise, the loss is greater. If our prediction is not good, okay, which has been expected, then obviously your model is in great loss. Okay, so our goal while training of a model is to find the weights and the bias and to lower the loss for the training purposes. The next thing is the accuracy. Okay, so accuracy is something which we calculate on the basis of the prediction. Okay, to equal a prediction, the predicted values and our labels, that is the existing values. So we are going to check whether they are mapping or not, whether they are match or not. Okay, so this is what our accuracy is. So it's one of the metric for evaluating the classification models. Okay, so accuracy is basically it's a fraction of predictions our model got right. Okay, so accuracy can also be defined as, or it can be also be formulated as the number of correct predictions as the total number of predictions with respect to the total number of predictions. Okay, so this is our code, and let me execute this code. Okay, so here it is 398. This is the value which I got it for train x underscore train dot shape one. Okay, I guess this is the value for x underscore train dot shape zero. Okay, 398. The next is your features. So your feature value is x underscore train dot shape one. Okay, these are the features. So we are available with the 30 features in our data set. Next, I have printed the summary of my model. Okay, so here it is, printed summary of my model. So dense layer with 30, expected output 30, the number of parameters are 310. Okay, so here I'm getting the output shape as none and a 10. Okay, none basically it's a batch size. Okay, so it's a variable, it's a batch size. So here we don't give, in general, we don't give the batch size internally. Okay, so that's why its value here has been coming to be none. Okay, so it's an internally the model interprets. Okay, so the output shape, the output batch is coming to be none, and here is the 10 units I've already told output. Then we have again created a dense layer, the same thing with the 10 outputs. Okay, so none and a 10. Okay, and the next thing is I have again used one more dense layer. You can see, you can check out from here. Okay, three dense layers I have used. Okay, so this is one more dense layer I have created. So again, here the output shape is one already defined. Okay, then the next thing is I have printed the configuration of the model. Okay, so here is a complete configuration of the model. Okay, that means all the details of your model. The next, I have printed the results. Okay, I have printed the results for the model. Okay, so if we talk about the results after your model, this is how your model got trained. Okay, this is how your model got trained for 100 times, because I have taken 100 epos. So model got trained for 100 pass. Okay, so here are the results. Okay, so this is the loss and this is the accuracy. Okay, and I have printed them separately after the evaluation. Okay, and if I want to execute the same code for the value output value of the dense layers as 5 instead of taking 10, because previously I took 10, now I can take 5, and just to check what is the output coming after that also, what will be the losses and what will the accuracy. Okay, so here you can check out, the loss is zero point 0.5 and the accuracy is zero point 0.5. Previously, the loss with the output 10 of the dense layer is your 7. Okay, accuracy is also more and loss is also more. Here, the accuracy is less. In fact, the loss is also less. Okay, so by adjusting your outputs for the dense layer, this is the output which we got. Okay, so that's all in this tutorial by using Keras implementation of neural network, and we will check ahead the further concepts of deep learning. Kindly do subscribe to my channel. Thanks for watching.